So today we'll be dealing with very large subnet mask, VLSM. Now, as you see here, we have a question. We have the address space 192.168.10.0. And here I have my different networks that will require these host addresses. So we have to find out first the network address, first host address, last host address, and broadcast address. So now how are we going to start? So I have this IP address 192.168.10.0, which I have to break for each of these networks. Now for VLSM, we have to start rearrange from largest to smallest. So first we have Memphis, which requires 18,780 host addresses. Second, we have Atlanta, which requires 7,845 host addresses. Then we have Montreal, which requires 1,022 host addresses. So now when we have done, we have to first break the IP address for each of these requirements. Now when I'm talking about these host addresses, means that Memphis here, this is a LAN. It could have 18,780 devices that will require IP addresses. Same for Atlanta. The LAN here could be required to provide host addresses for this number of IP devices. All right. So now let's start. We have to calculate for Memphis, which requires 18,780 host addresses. Now we have to use a formula. 2 power 2 minus 2 greater or equal to this number of host addresses, 18,780. Now 2 power n greater or equal to 18,782. Now when 2 power n, so see how I'm going to calculate the value of n. I know that 2 power 10 is 1024. When I multiply it by 2, it's 2048. When I multiply it by 2, it becomes to 4,096. I multiply it by 2, it comes to 8,192, I think. And 2 power 14 will come to 16,384. 2 power 15, we have to multiply it by 2. So 8 times 2, 16, 6, 7. I think it's 32,768. Now 18,782 and has to be greater or equal to, power n has to be greater or equal to. So this is too small. So now it's 15. N is equal to 15. So what does this 15 means? N means number of host bits. So see here, 192.168. How do we represent 10? This way. In binary, we represent 10 this way. Then we have this, which is the 0. So I take the IP address, that's one way of doing it. Then 15. I start from the right side, I start counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I need 15 host bits. So these 15 now represents host bits. And this represents network bit. So that's important. We have to know which part of our IP address represents host bits, which part represents the network portion. So because we're going to work with the host portion when we're going to put on the different devices. So network address, what we do to calculate network address. So to calculate network address. So we take the network address, that is, we take the IP address and perform an AND operation with the subnet mask. So when we perform an AND operation between the IP address and subnet mask, we obtain the network address. So let me remind you of something. When you do the AND operation, A, B, let's say this is 0, 0, 1, 1, 0, 1, 1. So A and B becomes, here it becomes 0, 0, 0, 1. AND means multiply. Okay, so now we're going to do it for this one. 255, wherever network portion is same, so it's 255, 255. It's the same here, so we keep it this way. Here we have only one bit as the network portion. The rest are host bits, so it becomes 1. So all the part of the network portion of a subnet mask is always 1. Because we have 8 ones here, it's 255. We have 8 ones here, we have 255. And this is only 1 here because only this bit, 0 bit, is in the network portion. And the rest in the subnet mask will come to 0. Now we are going to perform the AND operation to obtain the network address. So here we are multiplying with 1, we get 192. Here we multiply with 1, we get 168. Here 0, 1 comes to 0. Here we have 0, so it will be 0, 0, 0, 0, 0. And all here will become to 0. Now, the network address, this is a network address. Now we have to bring it back to the decimal form. So we are still for Memphis. Network address is now 192.168.0.0 because this is 0, this is 0. First host address is 192.168.0.1. First host would be 1 bit after the network address. Next, we have last host. So before we can calculate last host, we have to know the broadcast address. Now, something that you need to know is broadcast address. For broadcast address, we have to turn all host bits to 1. So here, as we see, we have here 192.168. As I told you, this bit is in the network portion, so it remains same. Then we have all these bits are in the host portion. So they'll turn to 1. Now, when we're going to calculate this, we have to calculate. So just to remind you, here it's 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. So when we're going to multiply all of it, we are going to add. It will come to 192.168.127.255. So this is now my broadcast address for Memphis. 192.168.127.255. So last host address would be 1 before the broadcast address. 192.168.127.254. All right. So next we have This network, first host, last host, broadcast address, subnet mask. So as you see here, this is the subnet mask, 255.255, okay. Next, what happens? We have only one here, and this position is 2 power 7. So that's why here it's 128.0, the subnet mask. So now let's see in the diagram. So I have calculated this. The network address here is 192.168.0.0. It's a slash. How many ones do we have in our subnet mask? 8, 16, 17 now. It's a slash 17. That's the idea of a number of ones in the subnet mask is 17. And the first host address, we can put first here. It depends. If the question asks you 15 first address to put here, put 15. You can put even .100 here. Good. Now we've done with Memphis, we have done. Now we have to do for Atlanta. For Atlanta, we need to give 7,845 host addresses. 2 power n minus 2 greater or equal to 7,845. So now 7,847. Because we put the 2 here. Now n, the value of n, the number of host bits that will be required. So let's see here again. We have 2 power 12, 4,096. 2 power 13 is 8,192. So obviously 4,096 is too small. So it can't be 12. So it has to be 13. N is equal to 13. Because 2 power 12 is smaller than this. We can't put 12. So 13 is more than this. So then it's okay. Now, the first network address. That's very important. The first network address will be this time one after the broadcast of Memphis. The last network we just calculated, 192.168.127.255 was the broadcast address of Memphis. So one after this would be the network address, 192.168. Now, we cannot, when we add 1, we can't have 256. The highest is 255. So now 1 comes here, 128.0. First host address will be 1 after the network address, 192.168.128.1. Last host would be 1 before the broadcast address. Now let's calculate the broadcast address for Atlanta. 192.168. Now we know that 13 bits are host bits. So 128, the representation in binary is like this. All right, this is the representation of the network address. Here, binary. So 13 host bits, 8, 9, 10, 11, 12, 13. All this represents host bits. All this represents network bits. So for broadcast, the network bit stays as it is. Host bits will turn to 1. So this we know it's 255. This is 31 plus this position is 128. So here it becomes to 159. So 192.168.159.255, 192.168.159.254 for the last host address. Now the subnet mask for this network, 255, 255, because the network portion didn't change. And here for subnet mask, I will be having, this is same, we have only these 3 bits in the subnet mask. So 255.255. So only these 3 bits are network portions here. And the rest here, it's the host portion. All this is network portion, all this. So this is my subnet mask. And these 3 comes to 224. Because 2 power 7 is 128 plus 64 plus 32, which gives me 224. So 224.0. So now we've done with Atlanta. So let me show you here. So 8, 8, 16, 17, 18, 19. This is a /19. That's the network address. So now we have to do for Montreal. Montreal, here. For Montreal, we have to give 1,022 host addresses. So Montreal requires 1,022 host addresses. Now 2 power n minus 2 greater or equal to 1,022. Here it's 1,024. So n is equal to 10. All right, so n is equal to 10. What does this mean? Now we have to have our network address. So as I told you before, network address is 1 after the last network which we calculated. The last network, the broadcast address of the last network, we add 1 to it. 192.168.160.0. Now first host would be 1 after the network address, 162.60.1. Now we have to know the broadcast address. Okay, so in that representation of 116 binary, 128 plus 32 is 160. All right, so this is the representation of 160, the network address. Now 10 of it will be the host bits. So all these are network bits. So for broadcast, 192.168.10.100, then we have 1, 1, 1, 2, 3, 4, 5, 6, 7, 8 ones here. So this is 255. Here it's 160 plus 1 plus 2 plus 3. So the broadcast address is 192.168.163.255, and here it is for last host address 163.254. And what about the subnet mask? So subnet mask 255.255. Now all these here will come to 1. So it will be 252.0. 255 minus 3 would be 252.0 for Montreal. So now for Montreal, the network is here. It's 192.168.160.0, which is a /16, 17, 18, 19, 20, 21. 16, 17, 18, 19, 20, 21, 22. /22. Now let's move to California, which requires 788 host addresses. So 2 power n minus 2 greater or equal to 788. Why do we make this calculation? To know how many host bits would be part of my IP address. So greater or equal to 790. So n is equal to, so let's see here, n is equal to 790. So 2 power 9 is 512. So n is equal to 9. No, n is equal to 10 because it has to be greater than 788, 512. 512 is lower than 788, so it cannot be 9. So it has to be it's greater than 512. So since it's greater than 512, n is equal to 10. Now, the network address would be one after the last one. And the last one we did was Montreal broadcast address. The next network address is .164.0. First host 192.168.164.1. Last host broadcast. So now we're going to calculate 192.168, 164. So here it's 128. So 164 minus 128. So 36 we have to give. So this is 64 here, no, 32. So I've given 32. I'm left with 4 to give. Good. So now we have to do find out the, here we have number of host bits 10. So which part of it is the host portion? This is the host portion. And this is the network portion. Now for broadcast address, so this remains same here. 11. No, this is 255. Now we have this, we know is 164 plus 1 plus 2, which 3, 168. Now 167.255. So 192.168.167.254. Now what is the subnet mask? N is equal to 10. Here also n is equal to 10. So we have the same subnet mask here. 255.255.252.0. Go back to Montreal to show you something. When n is equal to 10, it was 2 power n minus 2 greater or equal to 1022. 2 power n is greater or equal to 1024. And as we saw here, 2 power 10 is equal to 1024. We don't take the bigger one because greater or equal to. So it equals to 1024. That's why n is equal to 10. So now we're going to put for California here the IP address, the network address 164.0. which is a /22. All right, just like the one we did before, California and Montreal are same.